Welcome to the Deep Dive, your shortcut to being well-informed. Today we're plunging into a really exciting frontier. It's about running powerful artificial intelligence right there on your own machine, completely offline, total privacy. Imagine having this incredibly smart assistant, but it lives entirely inside your computer, no cloud needed. That's the whole promise of local large language models, LLMs. But here's the snag many people hit, myself included. If you're starting with mid-range hardware, you pretty quickly run into this frustrating VRAM wall when you try to load the bigger, more capable models. And it kind of leaves you feeling stuck, like you need a big, expensive hardware upgrade.
Right, and that's where it gets really interesting because the usual thinking is, well, bigger model equals better performance, which almost always means you need more powerful hardware, more expensive hardware. But this deep dive, we're going to explore something different, a kind of sweet spot solution, one that really challenges that idea, actually. It shows how intelligent design can sometimes beat sheer size.
Exactly. And that leads us straight to the star of our deep dive today, the Solar 10.7B LLM. So our mission for you, our listener, is to really unpack how this innovative open source model works, how it acts like a software-based supercharger, if you will, for those mid-range GPUs, proving that smart engineering can genuinely unlock a whole new level of performance from the gear you might already have. Okay, let's really dig into this problem first, the VRAM wall. Many of us, start our local AI journey with a graphics card, maybe like the Nvidia RTX 3060. And honestly, with its 12 GB of VRAM, it's a fantastic starting point. It really is. It handles those popular 8 billion parameter models pretty well. Parameters being like the model's knowledge points, essentially. Models like, say, Llama 3 run with impressive speed. It feels easy. It's an amazing way to get your feet wet. But then pretty quickly you start thinking, okay, this is cool, but can I push it further? Can I get even more capability without, breaking the bank for a new graphics card?
And that's exactly where the VRAM issue pops up. Video random access memory. Think of it like super fast, dedicated short-term memory just for your graphics card. When you run an LLM, almost the entire model needs to sit right there in that VRAM to run fast. So if the model's memory needs, its footprint, are bigger than the VRAM your GPU actually has, well, the card just can't load it. It physically can't. And that's when you hit those really annoying out-of-memory issues. Crash! That's the VRAM wall we're talking about. It stops a lot of people from trying out more powerful models, even if they're free and available. It's a hard limit, right? Feels very restrictive.
It really does. You hit that wall, and it feels like, okay, game over unless I spend more money. But this is where things got interesting for me personally. I started searching for a more powerful model, but one that crucially respected that 12 GB VRAM budget. And that search is what led me to Solar 10.7B. It's this incredibly efficient and powerful open source model. Yeah. And finding it, it really started shifting my perspective on things.
Yeah, it makes you wonder, how can a model be that powerful, but also so efficient with memory? Solar 10.7B really is kind of a masterpiece of LLM efficiency, and it's FOSS, free and open source software. It came from a South Korean AI startup called Upstage. And when it was released back in December 2023, the impact was pretty immediate, quite significant. It just shot right to the top of the Hugging Face open LLM leaderboard, which is a big deal. And what was so amazing wasn't just that it was good, it was outperforming models that were much, much bigger, way more complex. It's a classic case of a model that, punches well above its weight class.
That is fascinating. So they weren't just scaling up by adding more and more parameters, which seems to be the usual way?
Exactly, and not the brute force method.
So how did Upstage pull this off, this impressive performance, without just making it bigger?
They used this really clever, innovative technique called depth upscaling, DUS for short.
Depth upscaling. Okay, how does that work?
Well, the elegance of it is really neat. Instead of the usual path training, a massive 10.7 billion parameter model completely from scratch, which takes huge amounts of data, time, and money. They started with something already known to be excellent, the Mistral 7B model, a solid foundation. Then they intelligently scaled it up. They added new layers on top, essentially. But here's the clever bit. These new layers weren't random. They were initialized using the weights, the learned knowledge from the original Mistral layers. Think of it like building a skyscraper. Instead of digging a whole new foundation for extra height, you expertly add new floors that are designed to perfectly integrate with the strong existing structure below. This technique let them build a more powerful model on that strong base, drastically cutting down development time and cost. And crucially, that's what leads to its amazing performance-to-size ratio. It's really proof that working smarter in AI design can be better than just working bigger.
That sounds incredibly efficient. But are there any downsides to DUS? Does it change how the model learns fundamentally? Or maybe it's flexibility compared to one trained from zero.
That's a really good question. I mean, the beauty of DUS is that it builds on the really solid pre-training of Mr. Salsipi. So it starts with a good understanding of language. Sure, any scaling involves fine-tuning and adjustments, but DUS seems to keep a really remarkable level of coherence and ability to generalize. And the results, well, they really speak for themselves. For many tasks, the performance boost you get from this enhanced structure on a solid base. It seems to outweigh the theoretical idea of training purely from scratch. It's a pragmatic choice, It delivers results in the real world.
That makes a lot of sense. Okay, so let's bring it back to the user experience.
Yeah.
What does this actually mean when you sit down and use it? For me, getting Solar installed was surprisingly pretty straightforward. It had a few network things to sort out initially, but nothing major. But the bit that really made me sit up and take notice, it was just as fast as the smaller 8 billion parameter models I've been using. It's kind of counterintuitive, right? You'd expect a bigger, smarter model to be slower. But the speed was comparable, which was great. But the real game changer, the absolute wow moment, was the massive leap in factual accuracy.
Yeah, the source material gives a great example of this. It describes testing it with a query about the jazz legend Charlie Parker. With the older 8B models, the answers were often, well, filled with factual errors, just wrong information mixed in. And that's super frustrating if you're trying to use the AI for reliable info, right? It becomes more of a headache than a help.
Exactly. You end up double-checking everything.
Right.
But with Solar 10.7b, it was completely different, night and day. The response it gave was, and I quote, comprehensive, well-structured, and entirely accurate biography. It was seriously impressive, like it correctly identified him. Charles Christopher Yardbird, or Bird Parker Jr., better known as Charlie Parker, gave the correct dates. August 29th, 1920, March 12, 1955. Called him a highly influential American jazz saxophonist and composer. Spot on. It talked about his huge role in bebop, his virtuosity, his innovative approach. All correct. And it didn't shy away from the difficult parts either. It included the poignant but accurate detail about his turbulent personal life, the struggles with drug addiction, his untimely death at the age of 34, and how that death left an indelible mark on jazz music. It was just complete, nuanced, and factually solid, a demonstration of real knowledge and language skill.
That level of precision is really something. Does that kind of detail hold up across different topics, like more niche things or really current events? Or is it strongest on well-documented history, like Parker?
That's a fair point. From the testing I've seen and done, it seems remarkably consistent. I mean, sure, historical figures like Parker have tons written about them. But the model's ability to pull together information accurately, even complex stuff with lots of interwoven details, it suggests a pretty robust knowledge base underneath. It doesn't feel like it's just spitting back facts it memorized. It seems more like smart interpretation,
And that brings us to the key takeaway for you, the listener. This jump in factual accuracy. It means you get much more reliable results for whatever you're working on. Instead of constantly fact-checking the AI, you have a local assistant you can actually trust more. It really transforms it from maybe a fun toy into a genuinely powerful and dependable tool.
So let's tie this all together. What's the bottom line for someone listening who maybe has that 12 GB RTX 3060 or a similar kind of mid-range card?
Well, technically, it hits a real sweet spot, the quantized version of Solar 10.7b. And quantized just means it's been cleverly compressed. Uses less memory, but keeps most of its accuracy. Makes it much more practical for consumer GPUs. That version only uses about 6.2 gigabytes of VRAM. Now, on a 12 GB card like the 3060, that's perfect. It's a fantastic balance. It means you're leaving nearly half your VRAM free. And that free space is absolutely critical.
Yeah, that headroom is so important, isn't it, for handling the context of the conversation.
Yeah.
Because everything you type in your prompts, the whole chat history back and forth, plus the AI's replies, all that uses VRAM too.
Exactly.
So if your model already fills up almost all the VRAM just by loading, you can only have really short chats before you hit that memory limit again.
Right, it gets choked.
But with all that space, Solar 10.7b leaves free. You can have long, detailed, complex conversations. You can really explore ideas with your local AI without constantly worrying about hitting that frustrating out-of-memory wall. It genuinely opens up how you can interact with these things. Okay, so to wrap up our deep dive today, the main takeaway is this. If you're running a local LLM on a mid-range GPU, something in that 12 GB VRAM class, Solar 10.7b is, well, it's pretty much a must-try. Seriously consider it. It feels like a true software supercharge moment. It's a free software upgrade, remember. And it genuinely unlocks a whole new level of performance and accuracy from the hardware you already own. It's just a really compelling example of smart innovation making a difference.
And it circles back perfectly to that core insight, doesn't it? That intelligent model design, like Upstage's depth upscaling method, can give you a bigger performance jump than just blindly adding more parameters. It's a powerful reminder, really. In AI, like lots of areas, working smarter often beats just working bigger or harder.
Which leaves us with a final thought for you, the listener, to maybe chew on. How might this whole approach, this focus on intelligent design, like we see in Solar 10.7b, how might that change how we think about hardware upgrades in the AI world going forward? Are we maybe entering a time where clever software optimization becomes just as important, maybe even more important sometimes, than the next generation of silicon? And what other kinds of software superchargers might be hiding out there waiting to be found, tools that could unlock surprising potential in the tech we already have sitting on our desks? If you want to learn more about the company behind Solar, you can check out Upstage's website. It's upstage.ai. Definitely worth exploring.